Hi, welcome back. In this video, we're going to talk about another form of how to solve a cubic equation. Now, in the previous video, we spoke about how do you solve a cubic polynomial that's in this general format. And we spoke about the grouping method, where we split this into two parts. We grouped the equation into two parts, and then we were able to solve it separately. Now, for this other method, we're going to be looking at polynomials with just two terms. So something like this. The equation will look something like this with only two terms, and our goal is to use the SOAP method from our previous unit when we were talking about how do you factor a polynomial, the sum or difference of cubes. So if you would like more examples of how to factor it using the SOAP method, go to the previous video, the previous units, and check out sum and difference of cubes, specifically factoring. Now we're going to review that today, and we're going to talk about how do you solve it in addition to that. Let's get to it. So as you can see this example, we have our general form, where we have two terms. We're going to first take the cube root of both terms. Now the cube root of x cubed is x, because x times x times x is x cubed, right? Now the cube root of 8 is just 2 times 2 times 2. So we're going to be manipulating these two terms when we're solving this cubic equation in this format. So what did the SOAP method say? Well, SOAP stands for same, opposite, and always positive. Right? So we're going to take the signs and create our factors this way. Take the same sign. If we start with a minus, the problem is a minus. And then you change it to the opposite sign, which is a plus. And then the last sign is always positive. Right? This is same, opposite, always positive. And now I take these two terms and we plug them into our factors. So this becomes x minus 2 as my first factor. And then the second one, we're going to square the terms. X squared, 2 squared, and then I multiply the 2 to get the term in the middle, which is 2x. Now the idea here, this is the SOAP method. We're using the SOAP method to factor the difference of cubes. Once you find the factors, the idea is we can separate them and solve them as separate problems. And then I solve for x. On the left side, I move the 2 over. X equals 2. I got my first solution. On this one, I have three methods for quadratics. We got factoring, square root method, and we also have quadratic formula. Now, of the three methods, this is the one that we're going to be able to use today. Why? Because if I try to factor these, I cannot find two factors. 2 times 2 does not cross multiply and add up to 2x. Nor does 4 times 1. Right? If I do 4 times 1, I get 4x and 1x. There's no way to get a 3 out of these two factors. So this equation is non-factorable. Yeah? We cannot use factoring as an option. Now the square root method only works whenever we have one variable to isolate. And here we have two variables. So we cannot use the square root method either, which leaves us with the quadratic formula. We have to first identify the a value. A equals 1, b equals 2, and c equals 4. Because there's an imaginary 1 here, right? It's implied. There's one x squared. Now we're going to plug this to the quadratic formula. For this part, I did do a video previously on how to do the quadratic formula. And we're plugging it in to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times b. And I'm going to plug in a, b, and c. Negative b plus or minus b squared 4 times a times c divided by 2 times a. And then I just got to simplify a little bit. X equals -2 plus or minus the square root of 4 minus 4 times 1 is 4 times 4 is 16. Divide everything by 2. As I continue to simplify, we get -2 plus or minus -12 divided by 2. Now, if you remember back from Algebra 2 or a different algebra course, right, the square root of a -1 is equal to I. It's an imaginary number. That means that we do not have real roots in this scenario. We have imaginary roots because we're now dealing with a complex plane. So what does that mean for our problem? It means that I can change this. I can rewrite it as the square root of -12 is the same thing as saying the square root of 12 times the square root of -1. Now 12 you can simplify the same way as we did before. That's just 4 times 3. And I convert the square root of -1 to the letter I. Why is that? Well, -1 times -1 is +1. And +1 times +1 is +1. There is no way we can multiply two numbers identical to each other and get a square root of a -1 number. So we call this an imaginary number. Now, this simplifies to 2i radical 3. Square root of 4 is 2, the I comes in front of it, and the square root of 3 in the back. Just so that I don't confuse it with potentially having an I. Is it in here, the square root? Is it outside the square root? How do I separate these? We just put the variable in the front. Now I can simplify this and put it into my equation again. So I have x equals -2 plus or minus 2i radical 3. Everything divided by 2. We're pretty much done. Notice how here, all of these values are divisible by 2, so I can divide everything by 2, leaving me just with -2, this turns into -1 plus or minus 1i radical 3 divided by 1. Now, multiplying by 1 doesn't change this part, right? 1 times I is just I, and anything divided by 1 is itself. So I can write the answer as -1 plus or minus I radical 3. Here are my two solutions. And I was expecting at most 3. One of them is a real solution and the other two are imaginary. So the only new thing here that we're reviewing from Algebra 2 is the square root of a negative number. Any number. If you stick around to the very last of this video, I will show you how to simplify this negative square root, a few examples so that you can get the hang of this portion here. What happens when I square root a negative number? How do I simplify further? So let's try another one. Okay, so here, to start the SOAP method, right? Same, opposite, always positive. I need to first look at the signs. If I start with a plus, I will start with the same sign. This is plus. And then I go into the opposite sign. And the last one will always be positive. Always positive. Now, what numbers am I going to manipulate? Well, let's take the cube root. This is just the same as saying x times x times x. And this is the same thing as saying 4 times 4 times 4. So I'm going to be manipulating x and 4 into my factors. So I first plug in x and 4 in here. And then I start to square them, right? If I square this, I get x squared. If I square the 4, I get 16. And when I multiply them, I get the term in the middle, 4x. This is the SOAP method, right? This is what SOAP is all about. I am able to identify the factors of the sum or the difference of a cubic polynomial. Once I find the factors, my goal is to separate these and solve them separately. Now I just have to solve for x. here, and here. Since I'm dealing with a linear, I subtract 4 on both sides. X equals -4. That's the first solution. Here, since I'm dealing with a quadratic, I'm going to go with the quadratic formula. For this type of problem, we will always end up using the quadratic formula because this is also non-factorable and non-square rootable. So none of the other two methods will work. So if A equals 1 here, B is equal to -4, and C is equal to 16. I can now plug it into my general equation. -b plus or minus b squared minus 4 times a times c, all divided by 2 times a. Once you plug it into the quadratic formula, the idea here is that we simplify using PEMDAS. Right? Negative times a negative becomes a positive. -4 times -4 is positive 16. 4 times 1 is 4. 4 times 16 is 64. And I can divide everything times 2. As I continue to simplify, we got x equals 4 plus or minus the square root of -48 divided by 2. Now, how do I divide or simplify the square root of a -48? Let's do that over here. This is just saying 48 times -1, right? That -1 will turn into an imaginary number, the letter I. And 48 can be broken into several things. We can do 16 times 3. 4 times 12 would work. 6 times 8 would work. But I'm going to go with the highest perfect square, so that when I square root it, it comes out nicely to just 4. And then the I, I'm going to put it in front, square root 3. That way I don't put the square root 3 and the I next to each other. So I can replace that here. X equals 4 plus or minus 4i radical 3, all divided by 2. What do we notice here? These three terms are all divisible by 2. So that leaves me with 2 plus or minus 2i radical 3 over 1. Again, dividing by 1 does not change the problem. Right? Divide by 2. I do not want to divide the radical because the radical has its own like terms, right? Since 2 is not in the radical, I can't divide inside of the radical. So I can only simplify everything around it. And this gives me 2 plus or minus 2i radical 3. Because dividing by 1 does not change the problem at all. This is the gist of it, right? Can we apply the SOAP method to separate the two factors? Once you separate them, can you solve them separately? And in this case, we're going to have to do some more quadratic formula. If you're not comfortable with the quadratic formula, you can watch my other video, right, that I posted recently on the quadratic formula. Let's talk a little bit about simplifying square roots that are negative. Let's try some examples here, just in case you would like some more practice. Right? Like, let's say that we have the square root of -16. This is just us saying the square root of 16 times the square root of -1. Now, 16 has a square root. It's a perfect square. This is just 4. And square root of -1 is an imaginary number. It's 4i. What about like the square root of, say, -72? Well, this is just saying the square root of 72 times the square root of -1. 72 can be broken into 36 times 2. And 36 has a square root, which is just 6. The square root of -1 is I, and 2 stays inside. And you can do this for any number. Take what you already know about the square root, and then just account for the negative part. Square root of 50. This is just 50 times -1. 50 can be broken up as 25 times 2. And this is just I. 25 has a square root, which is 5. And then we attach the I next, and the square root stays inside with a 2. So whatever value you're dealing with, break it into the -1 component, and this -1 results with the imaginary component, the imaginary number. Would you like one more? All right. Let's say we have the square root of negative 8. How would you simplify the square root of negative 8? Well, this is just the square root of 80 times the square root of negative 1. 80 can be broken up into a lot of different factors. We have 8 times 10, 20 times 4, we have 16 times 5. I'm going to go with 16 times 5 because 16 has a perfect square. So the square root of 16 is 4. The square root of negative 1 turns into I, and the 5 stays inside the square root. See how our solution always has an imaginary value? That's because we have a negative inside the square root. And that's what's going to happen when you're solving these kind of problems. You're going to end up with some sort of negative inside the square root. Alright guys, I hope this has helped. Please let me know if you have any questions. Don't forget to like and subscribe. And as always, we'll calculate.